sure to work. And at that time, I had no results, right? I haven't done it. So there was no way to proceed by putting this in that way. And I am grateful to Stanford University, to the medical school, who risked and backed this work research. That's how it's been funded, that part. I'll share with you the other funding. The real cost is the mass spectrometer, okay? How did I get the mass spectrometer? I was able to convince my Air Force program officer that we were going to make somehow, by understanding what goes on in droplets, better jet fuel. I had no idea. I think my program officer also understood I had no idea. But this is the type of things that go on to make it happen, and I'm being honest about it all. But we'll continue. Okay. I think I want to tell you now the most recent work. And this has just come out, now watch, 2016 in PLOS Medicine. This is going to be publishing in this journal is a real pain. Anyways, this is going to be the molecular assessment of pancreatic cancer surgical resection margins by mass spectrometric imaging. If you have cancer of the pancreas, I'm sorry to say it's pretty much a death sentence. People don't know what to do still. I mean, that's the reality. And sorry. Anyways, and now this is work of Katie Markoulis in my laboratory, another postdoc. Okay? Again, we used 63 banked pancreatic cancer samples and 65 samples collected prospectively during 32 what they call pancreatectomies. You cut it out from 213 to 215. And the mass spectra for 254,235 individual pixels were evaluated. Can you see you're drowning in data soon? Each pixel getting 100 different methods, etc. Okay. When cross-validation was employed in the training set example, we got a 98.1% agreement was obtained in comparison to the histopathology. Okay. We used a novel statistical approach to evaluate the remaining mass spectra from samples with complex mixed histology, achieving an agreement of only 81%. I was really disappointed. You were doing so well, and this is only 81%. Okay? The developed method showed agreement with frozen section evaluation of specimen margins in 24 of 32 surgical cases. Look at that. I'm only getting 24 out of 32. Okay? In the remaining 8 patients, margins were found to be positive by what we did, but negative by the frozen section. Oh, this is not good, right? The median overall survival after resection was only 10 months for those 8 patients, as opposed to 26 months for patients with negative margins by both techniques. The observation suggests that our method, as opposed to the standard method to date, was able to detect tumor involvement at the margin in patients who developed early recurrence. Okay? Now, this isn't a proof yet, and you have to be cautious, but I'm trying to get you to see the possibilities here. This looks to me powerful. Okay? And of course, getting the doctors to agree to publish this, you have to really go through this process and convince them this is so. Okay? So we're going to move on, but you're getting some sense of this. And now I'm going to show you another combination. I hope you appreciate this. These are real problems. What are these problems? Do they belong to physics? Sure, the mass spectrometer. Do they belong to chemistry? Absolutely. It's we're lipids and things we're looking at. What else? It's biology, which we're going to talk about. You'll see this. And it certainly involves engineering, and it's being applied to medicine. It doesn't belong to any one field in an easy way. And you need people who have really strength in all these areas to come together to try to make this happen. Now I'll tell you about this work of a postdoc, brilliant postdoc, who just has an offer now to join the new ISER at Tirupati. Tirupati, right? Roman Banerjee. You've met Rob Tipchirani before. These people are pathologists, and this person here, again, cuts people up. The surgeon at Stanford. Okay, great. These are the players, different group. And in this case, we're going to be looking at prostate cancer. Now, we just as well could have looked at breast cancer. Okay? We're equal opportunity here. But we happened to, this group was working on prostate cancer. And here are the key statistics of prostate cancer. Most common cancer in men, occurs mainly in older men. And here's the facts. Many people will have it, few will die of it, but some do. One man in 7 are diagnosed with prostate cancer during his lifetime. It's the second leading cause of cancer death in American men. Okay, how is it diagnosed? People use this PSA blood test. Okay, but it's so confusing that it tends to cause more troubles than it's solving in many cases. People are worried about it. Okay, other things involve transrectal ultrasound, sound wave to construct the image of the prostate biopsy, and actually take out pieces and look at it under the microscope. You want to use the mass spectrometer. Or other techniques are things like MRI, but MRI doesn't have any resolution compared to what we need, like a surgeon's knife, right? It tends to be millimeters, so it's not so good. Okay, and I'm gonna show you a change. We're gonna look at small metabolites. And here are the small, this is from a typical prostate tissue. And so here you see pyruvate, you see lactate. You can read these. I hope you can see them. Erythros, taurine. Okay. Here's malate. Here's citrate. Here's glucose. Okay. Aconitane. And here's to my surprise was salicylic acid. Okay. And each one of these has been truly identified by high mass accuracy, the isotope distribution, the tandem MS, and comparing with standards. So we really